Hey everybody, and welcome to our deep dive. For anyone who works around cranes, this deep dive is for you. So whether you're a seasoned operator or a safety pro, keeping an eye on those massive machines, we're going to be looking at OSHA's 1926.1401. And that's all about, definitions related to cranes and derricks in construction.
That's right.
You might think definitions kind of boring, but trust me, these terms, they're the foundation of everything when it comes to keeping crane operations safe.
Absolutely. It's just like building a house. You got to have a solid foundation, and that foundation is a clear understanding of the language that we're all using when we're talking about crane safety.
Exactly. And imagine like you're on a busy construction site. Cranes are swinging these huge loads overhead.
Right.
How can you, as a safety professional, ensure that everybody on that site, goes home safe at the end of the day?
Right.
Or if you're the one operating that crane, how can you be confident that you're doing everything, by the book and keeping yourself and everybody else safe? It all starts with understanding these key terms.
Yeah, absolutely. And sometimes those terms can be a little tricky.
Yeah.
For instance, we have assembly disassembly. Now, this term becomes even more important when we're talking about tower cranes.
Yeah, I saw that OSHA actually uses different terms when it comes to tower cranes. Like instead of assembly, they use erecting and climbing, and dismantling replaces disassembly.
Right.
Why is that? What makes tower cranes so special?
Well, tower cranes are very unique because of their height and how they're constructed. The process of putting them together and taking them apart are much more complex than, with other types of cranes. So to be extra clear and avoid any confusion, OSHA decided to use very specific terms when it comes to tower crane assembly and disassembly. So erecting and climbing. That refers to the process of building the crane upwards section by section. Dismantling describes the reverse process, carefully taking the crane down piece by piece.
Okay, that makes sense. It's all about minimizing confusion, all these complex tower crane projects.
Yeah.
So for our listeners out there who work on tower cranes, understanding this subtle difference in terminology is really key. It's not just semantics. It's about, recognizing those specific procedures involved in each phase and making sure that everyone's on the same page.
Precisely. And speaking of clarity, another term that's super important, especially when you're working around power lines, is dedicated spotter. Power lines.
Okay.
And this isn't just any spotter. It's someone who has to meet specific qualifications that are actually outlined in OSHA 1926.1428, which covers signal person qualifications.
Now, power lines and cranes, that's a combination that always makes me nervous.
Yeah.
Could you break down why having a dedicated spotter in that scenario is so critical?
You're right to be concerned. Electricity is very unforgiving.
Yeah.
A dedicated spotter in this situation is laser focused on one thing, monitoring the distance between the cranes, the load line, and those power lines. They're the eyes in the sky. Constantly communicating with the crane operator, making sure that everyone stays a safe distance from those high voltage lines.
So they're trained specifically for this high-risk task.
Yeah.
According to OSHA standards. Kind of like an extra layer of protection when you're dealing with the invisible but very real dangers of electricity.
Exactly. And now let's talk about a term that I think really paints a vivid picture of a potential hazard on a crane site.
Okay.
And that is tube blocking.
Okay, tube blocking. What exactly happens here, and why is it such a big deal for, say, a crane operator who's in the middle of a lift?
Tube blocking is a situation where a component on the hoist line, like the hook block, comes into contact with the boom tip or a fixed upper block.
Yeah.
Imagine you keep reeling in that hoist line.
Okay.
And it's like trying to cram two objects into the same space.
Yeah.
Something's got to give. That continued force can snap the hoist rope, it can damage the crane, and in the worst case scenario, cause a catastrophic accident, especially if you're lifting a heavy load.
Oh, that's a terrifying thought.
So for our listeners out there, knowing this term and recognizing the signs of tube blocking could be the difference between, a safe lift and a disaster.
Absolutely.
Yeah.
As an operator, if you see that hook block getting too close to the boom tip, you need to stop the operation immediately and reassess the situation. It's a clear sign that something's wrong.
Yeah, it sounds like this is one of those terms, where knowing the definition can actually save lives.
You got it. And there are other terms that are just as critical for safe crane operation. So let's shift gears a little bit and talk about load moment indicator and load moment limiter.
Okay.
They sound kind of similar, but they play very distinct roles in preventing crane overloads, which is a major concern, for both safety professionals and operators.
Yeah, those terms definitely caught my eye too. What's the difference and why are they so important for, keeping things safe on a job site?
Well, think of the load moment indicator as like the gauges on your car's dashboard.
It gives the crane operator, real-time information about the crane's status, how much weight it's lifting, how far out that load is extended, which we call the radius. This information helps the operator stay within the crane's safe lifting capacity.
So it's like a constant feedback loop, letting the operator know how close they are to pushing the crane's limits.
Right.
But what happens if they get too close to those limits? That's where the load moment limiter comes in, right?
Exactly. The load moment limiter is like the crane's emergency brake system. If the operator tries to lift too much weight or extend the boom too far, the limiter kicks in and prevents those actions. It automatically shuts off power to the crane functions that could cause an overload.
Wow, that's incredible. So one provides information while the other acts as a safeguard. For our listeners who operate cranes, understanding how these two systems work together is, vital for preventing accidents.
Couldn't agree more. Now let's talk about a term that might sound a little scary, especially for those new to crane operations: free fall of the load line.
Okay, free fall. Just hearing those words in relation to a heavy load, suspended in the air, sends shivers down my spine.
Yeah.
What exactly does it mean, and why is it such a concern, for safety professionals?
You're right to be concerned. Free fall means that the load is descending using only the brake for control.
Okay.
The drive mechanism, which normally helps regulate that speed, is not being used.
So it's like taking your foot off the brake pedal in a car.
Yeah.
And just letting gravity take over.
Right.
Except in this case, we're talking about a potentially massive load, not just a car.
That's a good analogy.
Yeah.
Now, while there might be rare controlled situations where a free fall is acceptable, generally it's a very dangerous practice. If a heavy load were to suddenly drop uncontrolled, the consequences could be disastrous.
Yeah, it doesn't take much imagination to picture the damage and potential injuries that could result. So for our listeners who work on crane sites, recognizing a free fall situation and understanding the risks is, critical.
Absolutely. It's a situation that demands immediate attention and corrective action. Now, shifting gears to something that might be less familiar, let's discuss free surface effect.
Okay, free surface effect. That one sounds a bit more technical.
Yeah.
What's it all about, and why should crane operators and safety professionals, especially those working on marine construction projects, pay close attention to it?
This term is especially important when you're dealing with cranes on barges or other floating platforms.
Right.
Free surface effect refers to the movement of liquids within compartments on those platforms. Think about a partially filled tank on a barge.
Okay.
As the barge moves, the liquid inside sloshes around.
Okay, I can picture that. But why is a little sloshing such a big deal?
That sloshing might seem harmless, but it can actually shift the barge's center of gravity, making it unstable.
Oh.
Remember that cup of coffee analogy we used earlier?
Right.
Same principle, just on a much larger scale.
Right. Now I see where you're going with this.
Yeah.
So if you're operating a crane on a barge, and that barge suddenly becomes unstable because of free surface effect, that could spell disaster.
Exactly. It's a factor that needs to be carefully considered during planning, loading, and operation to ensure stability and prevent accidents, especially when you're working on water.
So for our listeners who work on marine construction projects, this term is one to remember. But even if you're working on land, understanding the basics of stability and center of gravity is crucial for any crane operation.
That's a great point. Now let's move on to something that's like having a co-pilot in the crane world: operational aids.
Operational aids. I like the sound of that. What exactly are they, and how do they make crane operations safer, for everyone involved?
Well, operational aids are devices that are designed to enhance safety by providing the crane operator with critical information or even taking control in specific situations. They're like high-tech safety features that can help prevent accidents. And OSHA actually has a whole section, 1926.1416, that lists these aids.
So it's not just about the operator skill. It's about having the right tools to support safe crane operations. What are some examples of these operational aids that our listeners might encounter on a job site?
One example is a boom angle indicator.
Okay.
This device tells the operator the angle of the boom relative to the ground, which is crucial for maintaining stability, especially when lifting heavy loads. If the boom angle gets too steep, the crane could tip over.
Right.
The boom angle indicator gives the operator that vital information so they can adjust the boom accordingly.
That makes sense. It's like having, an extra set of eyes watching out for potential instability.
Yeah.
What about other aids? Are there any that can help prevent those two blocking situations that we talked about earlier?
You're thinking along the right lines. We have the boom hoist limiting device. This clever device automatically disengages the boom hoist power when the boom reaches a predetermined angle, preventing it from going too high and potentially causing a two blocking scenario. It's like a
Yeah.
safety net.
Stopping the operator from making a dangerous mistake.
So for our listeners who operate cranes, being familiar with these operational aids and how they work can really make a difference in terms of safety. It's all about using technology to enhance awareness and prevent those oh no moments on a job site.
Precisely. And now let's talk about a term that's relevant to everyone on a construction site, not just crane operators. And that's the fall zone.
Fall zone. That sounds pretty self-explanatory, but I'm guessing there's more to it than just the area directly beneath the suspended load. What exactly defines a fall zone, and why is it so important to be aware of it even if you're not the one operating the crane?
You're right, it's not as simple as it sounds. A fall zone is any area where it's reasonably foreseeable that something could fall during a crane operation.
Okay.
It's not just about the load itself. It could include rigging components, tools, or even parts of the crane that become detached or dislodged.
So it's a much broader area than you might initially think. And because cranes often work at significant heights, the potential consequences of something falling from that height are obviously serious.
Exactly. That's why it's so important for safety professionals to clearly define the fall zone for each lift and ensure that everyone on site is aware of its boundaries.
Right.
Barricades, warning signs, and clear communication are essential.
And what about the crane operator? What's their role in managing the fall zone and minimizing the risks?
The crane operator plays a crucial role.
Yeah.
They need to operate the crane smoothly and carefully, avoiding sudden movements that could cause objects to swing or become dislodged. It's all about precision and control.
Smooth and steady wins the race, as they say.
Yeah.
Now, I know we've mentioned competent person a few times throughout this deep dive.
Right.
Can we unpack that term a bit more? What does it mean in the context of crane operations, and who qualifies as a competent person?
A competent person in the world of cranes is someone who has the knowledge, training, and experience to identify and mitigate hazards associated with crane operations.
Okay.
They're like the on-site safety expert, the go-to person for all things crane-related. They might be involved in inspecting the crane, rigging the load, or supervising the lift.
So it's not just a title, it's about having a deep understanding of crane safety and the authority to make decisions that keep everyone safe. For those of you listening who are, aspiring to be crane operators, this could be a potential career path, right? You could gain the experience and knowledge to become a competent person down the line.
Absolutely. It's a great way to advance your career in the crane industry and really make a difference in terms of safety.
Now, we've been talking a lot about safety precautions, but let's take a moment to, appreciate the amazing variety of cranes out there. The OSHA document mentions a few specific types, like mobile cranes, tower cranes, and even floating cranes derricks.
Right.
Understanding their unique characteristics is important for both safety professionals and crane operators.
You're absolutely right. It's all about choosing the right crane for the right job and knowing the specific hazards and safety protocols that go with each type.
Yeah.
Mobile cranes, for example, are those versatile workhorses you see on many construction sites. They're designed to be easily moved between job sites, usually on wheels or tracks.
Yeah, they're the ones that can really get around adapting to different job site conditions. And then we have the giants of the crane world, the tower cranes, reaching impressive heights and often dominating city skylines.
Exactly. And because they're fixed in place and often used for high-rise construction, they come with their own set of safety considerations.
Right.
Which is why OSHA has those specific terms for their assembly and disassembly.
And then we have the floating cranes derricks, the seafaring members of the crane family. They're out there tackling projects on the water like bridge construction or offshore oil rig work. And as we discussed earlier, operating a crane on water introduces a whole other level of complexity, especially when you consider things like free surface effect.
It's amazing, isn't it? The world of cranes is so diverse, and each type of crane has its own personality, so to speak. But no matter what type of crane you're dealing with, safety always comes first.
Well said. Now, before we wrap up this deep dive into crane safety definitions, there's one more term I'd like to touch on: bosun's chair. It sounds a little out of place in this construction context.
Yeah.
What exactly is a bosun's chair, and what are the key safety considerations when it's used on a job site?
Yes. The bosun's chair. It's a type of suspended scaffold designed for one person.
Okay.
Typically used for tasks that require access to elevated areas like inspecting bridges or the sides of buildings. Imagine someone hanging from a rope perched in a seat. It's kind of like a swing for construction workers.
Okay, I can picture that. But it also sounds a bit precarious. What are the key things to watch out for to ensure the worker's safety?
Safety is paramount when using a bosun's chair. First and foremost, the chair itself and the entire suspension system need to be meticulously inspected and maintained. The worker using the chair must wear a full body harness and be attached to a separate lifeline independent of the chair's suspension. Redundancy is key here. Multiple layers of protection.
Right.
And of course, a competent person should be involved in planning and overseeing the use of a bosun's chair.
Got it. So it's all about checks and balances, making sure everything is in top condition and that the worker is properly protected.
Uh-huh.
Now let's talk about a term that sounds like it comes straight out of a physics textbook, center of gravity. What does it mean in the context of crane operations, and why should crane operators and those working around cranes, care about it?
Center of gravity is a fundamental concept in physics that's crucial for crane safety. It's the point where an object's weight is evenly distributed. Think of it as the balancing point. When a crane lifts a load, that load has a center of gravity. If that center of gravity isn't properly accounted for, the load could shift during the lift, causing it to swing unpredictably or even tipping the crane over.
So knowing where that balancing point is located is essential for maintaining stability during a lift. How do crane operators learn to determine or estimate the center of gravity for different loads?
It's a combination of experience training and using the right tools.
Yeah.
Experienced operators develop a feel for it, but there are also techniques that can help. Sometimes the loads manufacturer will provide information about its center of gravity. Other times it might involve using load charts, visual assessments, or even specialized software.
It sounds like a skill that takes time and practice to master. Speaking of things that affect a crane's lifting capabilities, let's talk about rated capacity. What exactly does this mean, and why is it so important for crane operators to be aware of it?
Rated capacity is like the crane's weight limit, but it's not a fixed number. It's the maximum weight a crane can safely lift under specific conditions.
Okay.
This capacity changes depending on factors like the boom length, the radius, how far out the load is extended, and the configuration of the crane. The further out the load is extended, the more stress it puts on the crane, reducing its lifting capacity.
So it's a dynamic value that changes based on how the crane is set up and how far out the load is being lifted. This is where those load moment indicators and load moment limiters we talked about earlier come into play, right?
Exactly.
They help the operators stay within those safe operating limits.
Exactly. Those systems are crucial for preventing overloads and ensuring the crane operates within its rated capacity. For our listeners who are aspiring to be crane operators, understanding this concept is essential for safe crane operation.
Well, I think we've covered a lot of ground today exploring a whole world of definitions that are crucial for anyone involved in crane operations. It's been fascinating to delve into the language of train safety and see how each term plays a role in keeping those massive machines operating safely and efficiently.
I agree. Precision and clarity are so important in this field. A misunderstanding or misinterpretation of even a single term can have serious consequences.
So for our listeners out there, whether you're a seasoned crane operator, a safety professional, or just starting out in this field, take these definitions to heart. They're not just words on paper. They're the foundation of safe crane operations.
And remember, learning is an ongoing process. Stay curious, ask questions, and always strive to deepen your knowledge of crane safety. It's a fascinating and constantly evolving field.
Well said. And on that note, we'll wrap up this deep dive. But before we go, we'd like to leave you with something to think about. Imagine you're explaining these terms to someone new to the world of cranes. How would you convey the importance of understanding these definitions and the impact they have on the safety of everyone on a job site?